Hi, this is Mike, and this video is in regards to homework 4, and I wanted just to highlight a few things that I saw from the homeworks. And first of all, everyone did a really great job of actually following through with Dr. Bauer's video and actually constructing these objects, which is essentially the whole point of this class. As such, I was fairly lenient on the reasoning for how these objects were being traced, in particular with the tangent line. And so I wanted to address that and then also show an example of student work for the extra credit. So for the tangent line here, I actually have it pulled up here on the video screen. And I just want to point out that essentially what you have here are similar triangles. And the similar triangles, if you don't see them, are triangles B, C, and D here, and then triangles B, E, and A. So again, I'm not familiar with everyone's background, obviously, but the reasoning for similar triangles, as far as proving how two triangles are similar, there's these kind of three methods that we might be familiar with, which is the angle-angle, or the side-angle-side, or side-side-side reasoning for why two triangles are similar. And so I saw a couple students actually prove that these two triangles were indeed similar, and one way you can do it is just by stating that angle B here is the same angle for both triangles, and then also angle D here, because this line is perpendicular with this line, and EA is perpendicular with the same line. You have the same angles here, and therefore the other angles must be equal as well, and therefore you have similar triangles. But the other thing to point out also is why that matters. So because you have similar triangles, you have equivalent proportions with respect to two sides. And how does that relate to our graph here? Well, what is tangent but opposite over adjacent, or a ratio of the two sides of a triangle? And so since you have tangent being opposite over adjacent for this triangle, it's going to be exactly the same as the opposite over adjacent for this triangle. And so that is why, as Dr. Bauer might have asked you to figure out, why this length here of EA actually gives us the value of the tangent. Then I wanted to also point out an extra credit. So one student's work was really nice in demonstrating the cotangent. And I guess between the two pictures you might see, well, we created a perpendicular line here at A, but to actually do the cotangent, what you want to do is make a perpendicular line at the center. And then what you want to do is construct the distance between the parallel line that is parallel to your radius with point C here, and actually identify the intersection here at F between the line where FA and the line that is parallel to your radius here. So as you can see, as I go about the circle, the distance here between FA corresponds to the distance that I have here for my cotangent. And so just to summarize, having this length EA take care of our tangent is equivalent to having our distance here with FA, which is essentially 1 over the tangent, right? And the way you do that is by creating a parallel line here that cuts through this horizontal line here. So I'm not sure that that's the best explanation. If you have any questions, feel free to post them on the discussion board, and have a good week. Thank you very much.